Hello, welcome back. In the previous few lectures, we looked at ways in which we can solve LP problems. We looked at the graphical techniques if we work in a two-dimensional space, in other words, where we have only two decision variables. Now, in this lecture, we're going to look at formulating an LP model. That means when we take a real problem and we transform it or translate it into a mathematical model. Now, the best way to illustrate how one would go about is to look at an example. And we will look at example 54. This is a very simple example, but we will go through the whole process of formulating an LP problem from a realistic situation. A filling station needs to order petrol and diesel to sell to their clients. The cost of 1 ton of petrol is 8,000 rands and the cost of 1 ton of diesel is 9,000 rands. The net profit from selling a ton of petrol is 1,600 and the net profit from selling a ton of diesel is 2,000 rands. The total funds available for the purchase are limited by 100,000 rands. Due to the reservoir sizes, the garage cannot purchase more than 8 tons of each fuel. How much petrol and how much diesel should be purchased to receive the maximum net profit? Now, when you want to rewrite this as a mathematical model, we are required to, first of all, identify the decision variables, then specify the constraints, and then also to specify the objective function. You will remember that the decision variables are the variables or the quantities that we would like to solve with our LP problem. So if we go back to our example and you read the very last sentence, how much petrol and how much diesel should be purchased to receive the maximum net profit? So our decision variables will be the amount of petrol and the amount of diesel that the garage purchase. So we can define our decision variables x1, the number of tons of petrol that the garage will purchase, and x2, the number of tons of diesel that the garage will purchase. So that's the first step. Then we have to identify our different constraints. If we read through this, we see that the cost of 1 ton of petrol is 8,000 rands, and the cost for 1 ton of diesel is 9,000 rands, and that we are limited by 100,000 rands. That's our first constraint. Then also, due to the storage limitations, we can store at a maximum of 8 tons of each fuel, 8 tons for petrol and 8 tons for diesel. So that would be constraints 2 and 3. So we can rewrite these constraints mathematically. First of all, for the first constraint, the cost for 1 ton of petrol is 8,000 rands, and we multiply it by x1, the number of tons of petrol, and then the cost for 1 ton of diesel is 9,000 rands, and we multiply it by x2, the number of tons of diesel bought, and the total purchase must be less than or equal to 100,000 rands. That's the maximum funds we have available. So this will be constraint 1. Then the storage space for x1 or for the tons of petrol is limited by 8. We cannot buy more than 8 tons of petrol. That's constraint 2. And then for constraint 3, the same for the diesel. The total amount of diesel purchased must be less than or equal to 8 tons because of storage limitations. And then lastly, we also have the non-negativity constraint, and that is that x1 and x2 cannot be negative numbers. They must be greater than or equal to 0. Okay, so these are the constraints. And then lastly, we would like to set up our objective function. If we read through our question again, The net profit from selling a ton of petrol is 1,600 and the net profit for selling a ton of diesel is 2,000 rands. So that is the profit that we can make, and we would like to find the maximum net profit. So our objective function would look like this. We can make a net profit of 1,600 for every ton of petrol sold and a net profit of 2,000 rands for every ton of diesel sold. And this objective function we would like to maximize. Now we can summarize this LP model in the following way. We define the decision variables first, and then we write down our objective function, which we would like to maximize, subject to the constraints. Okay, so this is a very simplified example of formulating an LP model, but the steps are clearly illustrated that we first need to define our decision variables. What do we want to solve with this problem? And then we have to clearly define the different constraints. And then also we have to formulate our objective function and whether we would like to maximize or to minimize the objective function.